We are now discussing about the parallel circuit. So basically this is how you build your parallel circuit. Let's suppose we have R1, R2, R3 and they are connected like this. So basically there is a point, and from that point you connect your resistors, okay, R1, R2 and R3. Now from these 2 points you connect to a battery. So when we have this circuit, basically you will have a total current I, okay, and this current will be flowing into your wires, and at this point A, let's call it A, this current I will be divided into 3 currents, okay. The one that flows into R1 is I1, the one that flows into R2 is I2, and then the one that flows into R3 is I3, okay. So we have learned the Kirchhoff law, basically saying that the total current coming into a point has to be equal with the current coming out from that point. So in this situation we have current I coming into point A, so that I equals to the total current coming out from point A, which is I1 plus I2 plus I3. So this is the main difference between the parallel circuit and the series, because in series you have seen that the current I is flowing through the current resistor 1, 2 and 3, and they are the same, basically the current I1, I2 and 3, but in parallel circuit they are not. So this is the relationship between the total current I and the current flowing to each resistor, okay, I1, I2 and I3. Now look, let's suppose we measure the voltage difference at R1. This is called V1, and we measure voltage difference at R2. Let's call it V2, and also we measure the voltage difference at R3, V3. So basically, if they are connected to the same point here, point A and also point B, their voltage difference are the same, right? So let me repeat again. If R1, R2 and R3 are connected to the same points here, point A and B, so their voltage difference are the same, or we can write that V1 equal to V2 equals to V3. Okay, so this is the second thing that also very important in the parallel circuit, basically saying that in the parallel resistors their voltage difference are the same. Okay, so remember these 2 important concepts. Now let's have a exercise. For example, okay, let me build the parallel circuit first. So we have R1, let's have 2 ohms here, and R2 3 ohms, and then R3 5 ohms, okay, and they are connected to a battery, okay, and the voltage of this battery is 10 volt. So when you have a parallel circuit like this, again the important thing is you need to think about a resistor, a total resistance, and let me call it RP, R parallel, okay. So this RP is connected the same as your circuit to a battery. So basically this is point A and B, and that's also point A and B, the same point, okay. So you can imagine we basically just change the circuit into a simpler circuit, RP, okay. Now how do we get the total resistance in the parallel circuit? Okay, if you look at again your current relationship here, so basically the current I, now look, if I draw your resistor into one single resistor, and let's call it RP, and this RP is connected to a battery, the same battery here, okay, so the current I here is just V divided by RP, right, because your resistance is RP. Therefore I can write this I as V divided by RP. Now, what about the I1? Well, if you look at your I1, you'll see that there's a current flowing into it, so that's I1, and that's I1 is just V1 divided by R1. And also with the other resistors, they are the same, basically, you know, V2 divided by R2, sorry, this is R1, and lastly this R3 is V3 divided by R3. Okay, now well, you know, actually the total voltage of your battery is also the same as V1, V2 and V3 because they are connected to the same point, so this is also the same as V. So if the voltage difference are the same, you can cancel them. Therefore, at the end of the day, we'll get the relation of your total resistance here. Okay, so that's basically just 1 over R parallel equals to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Okay, so this is how you calculate your total resistance in the parallel. But be careful, we still have 1 over R parallel. Therefore, when you calculate this, you need to inverse it at the end. Okay, now let's go back to our circuit. So, if we want to calculate this RP, and you have R1, R2, R3 are connected in parallel, therefore 1 over RP has to be 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so let's calculate this first. Okay, 1 over R parallel is 1 over 2 plus 1 over 3 plus 1 over 5. Now we have to have the same denominator, and that will be 30, right? So this is 15 plus 10 plus 6. Okay, is my calculation correct? Yes. So that will be 21 plus 10, 31 over 30. So that's 1 over RP. Therefore, your total resistance will be 30 over 31 ohms. Okay, so this one is 30 over 31 ohms. Good. Now, look at this. This resistor is connected to a battery, and that has the same voltage 10 volts here. So the current we will have is just this 10 volt divided by your total resistance, 30 over 31. So the total current will be 310 over 30, or if you want to simplify, you get 30 over 3 amps. Okay, so this is the total current. Well, maybe you see this is like a very long calculation, but if you get more practice, you will see this is actually not that difficult. Okay, now once we have this current is actually the same current here, 31 over 3, and it will be divided into 3 currents. Let's call it I1, I2, and I3. Okay, so how do we get now this current? Because you will be asked about how big this current. Okay, so look, this current here, 31 over 3, gets into this point, and from that point we have I1, I2 and I3 coming out. So it's the same as I1 plus I2 plus I3 according to Kirchhoff law. So now let's get the current I1, I2 and I3, okay? So if we just have a pure parallel circuit like this, and they are just connected to one battery 10 volt, basically the current I1, I2 and I3 is very simple. Okay, let me show you. So look, since they are connected to the same battery 10 volt, therefore I1 is just the current, the voltage of the battery 10 volt divided by this resistance. What is it? 2 ohms. Okay, so it will be 5 amps. And then this I2 is just this battery 10 volt because their potential difference are the same. Okay, and what is R2? Okay, 3 ohms. Therefore we got 10 over 3 amps. And then the last one will be I3, and this I3 is just the same voltage 10 volt divided by 5 ohms, right? So we have 2 amps. And as you can see here, the current that flowing into R1 2 ohms, this is 3, 5. So the smaller the resistance you have here, the current is the biggest one. But the biggest your resistor, 5 ohms here, the current will be the smallest one. Okay, so you can imagine the relationship between current and the resistor. The bigger your resistor, basically the current will be smaller, and the smaller your resistance, the current will be big. Okay.